Hello everyone and welcome to this class. So today we'll solve first chapter which is there in our Maths 1 book, linear equation. Linear equations in two variables. Okay, so what is a linear equation? Let's understand that. So this is a mathematical statement where I am saying x plus 3 is equals to 0, y plus 3 is equals to 0. So a mathematical statement with at least one variable and an equal to sign will be an equation. Okay, so this is an equation, this is also an equation, okay, where you will have two variables. Here the variable is x and here the variable is y. Okay, what is a variable? The value of this term is not constant, it will keep on changing. Okay, that is why it is called as variable. Now you can see many equations here that I had put in on the slide. Equation with degree 1, okay, is called as a linear equation. The highest power of the variable is 1. Let's check it out here. The power of x is 1. The power of y is 1. The highest power in the equation of a variable is 1. That is why it is called as a linear equation. When the power becomes 2, it will be called as a quadratic equation, okay, which will be our next chapter. This is not we are studying in today's class. So whenever the variable, this y is a variable here, the highest power of the variable here is 2. Okay, that's why it is a quadratic equation. So we are not studying such equations in this chapter. We are studying linear equations, which means the highest power of the variable is 1. So here you can see two variables, x and y. Okay, why are they called as variable? Because their value will keep on changing, will keep on varying. That's why they are called as variables. And their highest power is 1. Okay, that is why it is called as a linear equation. Okay, so what is a linear equation? Where the variable will have a highest power of 1. If it becomes 2, then it's a quadratic equation. So we got to know now what is a linear equation. So there will be a standard form of linear equation that you will see in your book, okay, which is given by this coefficient ax plus by plus c is equals to 0. Okay, so a here, if you can check, if you are comparing this equation, the standard form with this equation, a here is 1 in this, a here is 3. If you put it here b here is 1, b here is 5. Okay, and that is equal to the constant term. So plus c is equals to 0. c here is 5, c here is 9. So I can represent any equation in the standard form, ax plus by plus c is equals to 0. Okay, where a and b are constant, a, b and c, they are constant. Why are they called as constant? Because their value will be constant. This 3 will remain to be 3, this 5 will remain to be 5, 9 will remain to be 9, this 5 will remain to be 5, this will be 1 and this will be 1. So they are constant and they are always real numbers. Okay, that's what we know about it. A can't be equal to 0 and b can't be equal to 0. If they become equal to 0, it will not be an equation. There will be only constant term left, right? So that is what you call for as linear equation. Now, how do you solve a linear equation? Okay, so there are four methods here: eliminating by equating coefficients, elimination by substitution, then there is a graphical method, and in the end we have Cramer's rule. Okay, so we'll be studying all the four, but first and the foremost thing we need to understand is, do we apply linear equations in real life? What will you do after solving this equation? Is there any use of this equation in real life? That's what we understand now. Okay, then we'll understand the four methods of solving linear equation. So let's start first by asking ourselves a question: do we apply the concept of linear equation to solve real life problem? Let's see that. Now before we actually move on to understand various methods to solve linear equation, let us just understand, where do you apply the concept of linear equation in real life? Can you solve real life problem by using the concept of linear equation? So this is your practice set 1.5. We will not solve this problem, but we will just understand it here. How do we use the concept of linear equation in real life? Okay, so what is given here? Out of 1900 kilometers, Vishal traveled some distance by bus and some distance by aeroplane. Bus travel with the average speed of 60 km per hour and the average speed of aeroplane is 700 km per hour. It takes 5 hours for him to complete the journey. Okay, so what do you know? He is traveling some distance by bus and some distance by aeroplane, and it takes a complete 5 hours to complete the journey. Find the distance traveled by bus. Okay, now let's see how I make linear equation from this problem. Solving the linear equation, we'll see it in the next part, but how do you make a linear equation from this problem? Okay, so let's start. We shall travel some distance by bus, so let the distance traveled by bus be x. Let the distance traveled by aeroplane be y. These are my variables. Okay, we had seen linear equation as variable. These are my variables. So out of 1900 km, some distance is traveled by bus. So let the total distance be AB. Out of that, distance from A to C. Okay, I am saying that the Vishal traveled by bus, and from C to B he traveled by aeroplane. So let this distance be equal to x, A to C, and let this distance be equal to y from B to C. Okay, I am trying to make a linear equation now. So what do I know? X plus y is equals to what? 1900, because that is my total distance. That's how I make a linear equation. So there is a real life problem, but I am making an equation out of it. Okay, that's where you apply the concept of linear equation. But then now your x and y can take so many values, right? This can be 100, this can be 1800, this can be 200, this can be 1700, this can be 300, this can be 1600. That's why they are called as variables, because they can take many values. So I will need one more equation in terms of x and y to get the exact value of x and y, and I'll get that from the speed. Okay, so let's understand what is given here. The speed, let's make second equation from the speed. Okay, because as I said, x and y can take many values now. So what do we know? Bus, aeroplane, distance traveled by bus is x, distance traveled by aeroplane is y. The speed while he was traveling by bus is 60 km per hour, and the speed while he was traveling by aeroplane was 700 km per hour. So we know a simple formula: time is equals to distance upon speed. So the time required to travel by bus will be distance upon speed. Okay, so x upon 60 will be the time required to travel by bus. Similarly, the time required to travel by aeroplane will be y upon 700, distance upon speed. Distance traveled by aeroplane upon speed of the aeroplane. Total time taken is 5 hours, and the total time is time taken to travel by bus plus the time taken to travel by aeroplane. So total time is equals to 5. According to the second condition, I get this as an equation. Now these are my two equations. Okay, I will have to solve this two equation and get the exact value of x and y. How to solve them, we'll see it in the next part. Okay, the different ways to solve linear equation. But all that I am trying to say here is, this is how you apply the concept of linear equation in real life to solve real life problem. So whenever you see certain conditions, certain problems that are given, you make linear equation out of it, and then you solve them to get the exact value of x and y. Okay, we'll be solving them, we'll be learning how to solve them in the next part, but for the time being, we just know, okay, this is how you apply it in real life. Okay, let's see few more examples which will tell us the application of linear equation. So we come across one more real life problem, which is nothing but a solved example from our book. This will again tell us where do we apply linear equation in real life. So a certain amount is distributed among certain number of students. Each would get 2 less if 10 students were more, and each would get 6 more if 15 students were less. Find the number of students and the amount distributed. Okay, so how will you start solving this now? Find the number of students and amount distributed. So from this, I'll make a linear equation. Okay, and after that, we'll solve it to reach on to our answer. So how do you make a linear equation from a real life problem? Let's start thinking. So I have a basic idea. If 40 rupees is distributed among 2 children, how much will each one of them get? 20 rupees. That's quite easy. If 40 rupees is distributed among 4 children, then how much each one of them will get 10 rupees. That is also quite understandable. So 4 children, each one of them get rupees 10, total amount distributed is 40. So what do you understand from this? Number of students into amount given to each student is equals to the total amount distributed, right? From this I make the equation. So let the number of students be x, let the amount given to each student be y. So the total amount that will be distributed will be simple, x into y, right? That is quite understandable from this simple example. Okay, I am trying to make a linear equation now to solve this problem. Now what is the first condition? The first condition given here is each would get 2 less if 10 students were more. So now the number of students are x. According to this condition, number of students will be x plus 10 because 10 students are more, right? So now the number of students are x plus 10. So earlier if it was 40, now it is 50. Because of which what is happening? Each would get 2 less. So the amount distributed now will be what? Not y, y minus 2 because each of them is getting 2 less. And this is nothing but the total amount that they get. Okay, so this is equals to xy. Okay, similarly, what is the next condition? Each would get 6 less if 15 more students, and each would get 6 more, if 15 students were less. So now the number of students are x. Okay, let's just first solve this, then we'll make the second equation. So if I just solve this, x into y, this is 2x, this is 10y and minus 20 is equals to xy. xy gets cancelled, I get my linear equation. Okay, if I divide throughout by 2, I will get this as my equation. Okay, but I cannot find the value of x and y from this. So I need one more equation to find the exact value of x and y, which I'll get it from this. Each would get 6 more if 15 students were less. So number of students here are x. So now the students would be x minus 15. Because of which students are getting more. So amount given to each student now will be y plus 6. And that is nothing but the total amount that is being distributed. Okay, I hope you remember the example. If there are 4 students, each one of them gets 10. But if there are 2 students, each one of them gets 20. So if the number of students reduces, amount that each one will get will increase. Okay, that's what is happening here. Number of students are reducing. So amount that each one is getting is increasing, but that is my total amount. Here what is happening? The number of students are increasing. So amount that each one of them is getting is reducing. That is but nothing but your total amount. Okay, now I have 2 equations. So let's solve this. xy 15y 90, xy gets cancelled. I get 6x minus 15y is equals to 90. These are my 2 equations now. Dividing throughout by 3, I get this as an equation now. Now I need to know the method to solve this 2 equation, because till the time I know the method, I will never get my answer for x and y, and that is what they are asking, number of students and the amount that is being distributed to each student. Okay, I will not get the answer till the time I solve this 2 equation. Okay, so I need to know how to solve this equation, and that's what we are going to study in the next part. How to solve a linear equation. Okay, but before that, the most important question that we had is, do we apply linear equation in real life? Now we know it. So from the conditions we make linear equation. You can also see many conditions that are happening around you, right? So you can make linear equation from your life as well. But you need to solve the linear equation to reach on to the answer. Okay, because always you will assume that let this be x, let that be y. But eventually you have to find the value of x and y. Till the time you don't find the value, you will never find the solution for the real life problem, right? So we need to know now what are the methods to solve a linear equation. Okay, so let's jump on to that. After that, we'll be solving many such solved examples where we are applying the concept of linear equation to solve the real life problem.